So this video is showing when to recognize whether something can be factored maybe more than once. So I'm just looking at the one that we did the other day that was kind of a mixture of problems. And so always the first thing I do is I ask myself, can I factor something out of every term? And so looking at these ones, I cannot. On 1 through 4, 5 I cannot either. 6 I can. Okay, so on a problem like this, and like number 8 below, okay, and 9, these ones I can factor something out of every term. So on number 6, I can factor out a 4 and an x, and then I'm going to be left with a 3x minus 4. And I look to see if I can factor further, but I cannot factor this further. Okay. On 8, again, I look and I see, oh, I can take something from both of them. I can take a, let's see, I can take a 10 from both of them. I can actually take a 20 from both of them. So I'm going to take a 20 from both of them. I'm going to be left with a 2 minus 5m. And this 2 minus 5m, I cannot factor further. So both 6 and 8, I was left with what we would call a linear factor. And unless I can factor something out of the coefficient and the constant, the 3 and the 4 here, and the 2 and the 5 here, if I can't do that, I can't do any more factoring. Okay, because once you get down to the linear, where it is a degree 1, we call it, like this is x, but not an x squared, or m, but not an m squared, I should be done unless I can factor out a number. Now, on one like number 9, I can factor out something from each of these terms. I can factor out a 2. And when I factor out a 2, I get a 2x squared minus 5x minus 3. Now, when I factored that 2 out, I'm left with a trinomial with an x squared and an x. Maybe this can be factored further. Maybe it's not. Maybe that's all I can do, but let's try it. So I'm going to do a box to diamond. I'm going to put my 2x squared here and my negative 3 here. That's going to multiply to a negative 6x squared and add to my negative 5x in this trinomial. So that is going to end up being a negative 6x and an x. So one of these is a negative 6x and one of them's an x. Since I could do my diamond, I know it is factorable. Now, what we want to remember is that this 2 is still in my answer. And then I'm going to find the outside of this. The way I have it set up, this is going to be a 2x, this is going to be an x, this is going to be a plus 1, this is going to be a minus 3. So I get a 2x plus 1 and an x minus 3. So if I can factor something out of every term and I'm left with a trinomial like this, a quadratic, basically quadratic has a 2, x to the second, you might be able to factor it further. You want to take a look at that. Let's see, just looking at these. Now, if I look at number 18 here, okay, I see that I have a 3, a 9, and a 6, so I can factor something from each of those. I can factor a 3 out, and I'm left with an n squared plus 3n plus 2. So I have a quadratic here, okay, degree 2. So that probably is factorable. And that would be a diamond, okay? You can draw it or you can just think it. What multiplies to 2 and adds to 3? Well, that's going to be a 2 and a 1. So this is going to be 3 times n plus 1, n plus 2. And that will be my answer. Now, 19 again, I notice that I can factor something from every term. So I'm going to factor out a 2. And I get a 6t squared minus 5t plus 1. And again, we have a, we have a quadratic here. So chances are that might be factorable. So let's see, throw that in, 6t squared t That's going to be a 6t squared and add to a negative 5t. So that would be a negative 2t and a negative 3t. So a negative 2t and a negative 3t. I'll put my 2t here, my 3t here. 3t times a negative 1, 2t times a negative 1. Now, again, don't forget that this 2 is going to be part of my answer. And then I have my 3t minus 1 and my 2t minus 1. 21, I would do a similar situation. I can take a 5 from each of those. Then I want to see, hey, when I take that 5 and I'm left with a quadratic, can I factor that? So that's how those types are, okay? Same with 23, you can factor a 5 from it. Now 24, we can factor something from it, but what you'll notice is besides just factoring a 3, you can actually factor out an x. So on this one, I can factor out a 3x, and then I'm gonna have an x squared minus 2x minus 15. And then again, I have this, whoops, quadratic, okay, degree 2, polynomial is what we call it. And I can factor that. What multiplies to negative 15 and adds to a negative 2? Well, that's going to be a negative 5 and a positive 3. Okay, I can factor out on 26 a y from everything. Then I'm left with an x squared minus 3x minus 10, which I can factor. Okay, 23 again, I can factor out a 5, and then I'm left with something I can factor further. Now on one like 25, I can factor a 2, and I'm left with a 2, an x squared minus 25. Now this is a quadratic, it's a degree 2. It's not a trinomial, but it is still a quadratic. And that happens to be a difference of 2 squares. So x squared minus 25 is an x plus 5 and an x minus 5. And then I have that 2 in front. So don't forget the 2. Now, there were some that we had on our classwork from the other day. I'm going to get that up real quick and show you ones where maybe you can do a difference of 2 squares twice, or maybe perfect square and a difference. So let me pause for a second and get that open. So this worksheet was the one where we had all the special ones. We had perfect square trinomials, differences of 2 squares, and sum and difference of 2 cubes. So on some of these, what happens is when I factor them, I ended up with something that was factorable again. And so some of those cases were ones like number 7, number 8, number 9, number 10. Number 11, I could factor out a 2, and then I'm left with a difference of 2 squares. Number 12, I can factor out a 3, then I can factor that again. But let me take a look at these ones here in comparison to one like this one here. Okay. And then I'll take a look at one like this. So on these ones where it is to the 4th power, these ones are differences of 2 squares, because an n squared being squared is an n to the 4th. So this is going to be an n squared plus 10 and an n squared minus 10. So again, I'm left with quadratics or degree 2. The one with the plus and n squared with a plus number versus an n squared with a minus. The minus maybe, and actually for this one, I cannot factor this one further because 10 is not a perfect square. Okay. So, but I would want to look at it when I have an n to the 4th and I break it down and I got an n squared to n squared. Maybe I can take it further. So that one I can't. 8, 9, and 10 I can. So on this one here, this would be an a squared plus 1, which I cannot factor further. A squared minus 1, I can. This is a difference of 2 squares. Okay, so I could factor this where I keep the a squared plus 1, and then my a squared minus 1 is an a plus 1, a minus 1. So I had a difference of 2 squares in my difference of 2 squares. Same with this one. This would be a k squared plus 9 and a k squared minus 9. And so my k squared plus 9, I can't factor. That's going to stay. But my k squared minus 9 is the difference of two squares. K plus 3, k minus 3. One like number 10, again, n squared plus 4. Can't factor that further, but the n squared minus 4, I can. This is a difference of two squares. So I am going to have an n squared plus 4. And then my n squared minus 4 is going to be an n plus 2, n minus 2. So when you have differences of two squares with a fourth power, that means you're going to get squares. So you might get another difference of two squares. Here I did not, because 10 is not going to be a square. And here, this one I would not, because this would be an a squared plus 3, a squared minus 3. The one down here, a to the fourth minus 9. And 3 is not going to be a perfect square. So that I could just factor once. Again, 11, I could factor something out, and 12, and then factor again. Let's see. And I think those are probably the examples that most of the examples we're going to see. Let me just say this one. I can factor out a 9 from this. These are squares, and this could be a 9a squared plus 3 and a 9a squared minus 3. But I can factor a 9 out first, and I get a 9a to the fourth minus 1. And this 9a to the fourth minus 1 is a difference of two squares. So, whoops. So that is going to be a 3a squared plus 1 and a 3a squared minus 1. Now, these particular ones, I cannot factor further because 3 is not a square, okay? And the one with the plus, I cannot factor further. So hopefully that helps a little bit. If you need more, let me know.